Okay, well, I think we'll start the presentation now. Thank you all very much for joining us. We really appreciate you giving up your time. Tony is a very experienced author, and he's going to take you through now consolidation and catch up, which I think from what we're just reading in the chat box is going to be very appropriate, and then talk about the concrete pictorial abstract approach for teaching mathematics. Thank you very much, Tony.
Thank you, and thanks everybody for coming. It's nice to speak. It's nice to speak to you. And maybe what we'll be thinking about, as some of you, Joan was saying that you've got a blended approach where you are, and Gabriel and Alicia and Norda were all saying that it's certainly in Jamaica and Trinidad and Tobago the kids are all still off school. Part of what we'll be thinking about is what you might be doing once the children return to school. In the UK, the children returned to school a couple of months ago, and there was a lot of discussion around catch up and what that might mean. So I'm going to kind of explore a little bit what we might mean by catching up, and how we might do that or meet the requirements of this kind of catching up agenda through thinking about what the kids have done over the last year or so, and how we can build on what they have done, how we can find out where they've got themselves to, and build on that. And I think probably to preempt my main message, it is always about not panicking and not feeling as though for some reason everybody is suddenly behind, and that we've got to do lots of what you might call remedial work. That actually there's still, particularly for those of us teaching primary age children, or for those of us with primary age children, there's a lot of time available for them to learn plenty of mathematics. And then later on there was also a request to think a little bit about the concrete pictorial abstract approach, and how those things might fit together, but particularly what the CPA approach looks like in mathematics. There's an alternative version of me. One of the things that I do is that I'm a member of the Association of Teachers of Mathematics in the UK. I have been their honorary secretary, and currently I edit their journal, which is an international journal. And that's given me, I suppose, access to a lot of thinking around the sorts of things that we're talking about. And that's me when we used to be able to have face-to-face conferences. The conference, like many other things, has been online this year. I think one of the things that's been interesting in the last year, and maybe one of the things that we've learned through the pandemic, is how we can collaborate globally. So whereas previously, so I've written for Macmillan, and I've written a program for Jamaica called Explore Maths, and I've written a program for Belize. And normally what we would have done is that I would have visited and worked with teachers on workshops. Now, of course, that's wonderful for me. But I suppose what we've been able to do in the last year is actually more people have had access to the workshops when they've been remote workshops. So the workshops I ran for Belize teachers were attended by almost a third of all of the teachers in Belize, and we couldn't have fitted them in a room. So that was quite efficient. I've also done various other webinars for teachers in international schools, and we've ended up talking to, I think that my record is something like 300 teachers on one of these sessions, from 260 countries, which again is something that would have been absolutely impossible to do face to face. So there's kind of access to professional development has become much more equitable, I think, although there are the issues of access to the internet. And one of you was talking about that one of the problems in terms of children learning at home is access to the internet. And on Monday, I'm running a workshop, an international workshop with Macmillan, which looks at maybe how we can work with people at home. So that might be something that you're interested in. You'll see that I say on that slide, I believe our understanding of mathematics impacts on our understanding of the world. let me explain a little bit about what I mean by that. And I think this is the reason why I think mathematics is important, and why I think learning and teaching mathematics is important. So this is why I want to look at this at the very beginning. If I had been to face-to-face Association of Teachers of Maths conference, as I am in that image, I'd have been running a workshop with my wife around drama in mathematics. And the workshop that we had planned for last year was looking at and it's a story from the UK about a village when there was a plague in the UK in the 15th century. And there's all sorts of stories came out of that. And the village actually isolated itself as a way of making sure the plague didn't spread. Now, obviously, that kind of suddenly became very pertinent. And one of the things that we would have done was a modelling activity. And I'll explain this modelling activity because I think it shows what I mean by that second statement. So if I was with you in the Caribbean and say there were 30 of us in the room, what I would do is give each of you a small piece of paper. Now, out of those 30 people, one person on their small piece of paper would have a little cross. And I'd say to you, okay, I want you to mill around the room, please, and then stop and pair up with somebody. And if you happen to pair up with somebody, with the person who has the cross on the piece of paper, you've caught the virus. And we repeat that for 4 or 5 different rounds. Then I might say, how many people do you think now are carrying the virus? And then we'd look at the results and discuss how close we were to the estimate, and what the maximum might have been and what the minimum might have been. And as you can see, that's quite a good way of modelling how something like a virus spreads. Now we can take that further, and I've done this since in some classrooms here. So we can look at the data on how coronavirus spreads, and we can say, okay, now what we've introduced is social distancing, and what social distancing does is halve your chance of catching the virus. So this time we rerun the modelling activity. If you meet up with somebody with a cross on their piece of paper, you roll a dice, and you only catch the virus if you roll an even number. If you roll an odd number, you've been protected. And we will rerun it for 4 or 5 rounds and compare the results. We could do it again. We could say we're introducing masks, and we'll assume that means there's only a 1 in 10 chance of catching the virus, or it actually is only a 1 in 10 chance of catching the virus if you've had a vaccination. We can rerun it. We can roll a 10-sided dice, and you only catch the virus if you roll a 1. So suddenly you can see that by having an understanding of the mathematics, it might actually impact on the way that you operate in the world. And that's why mathematics is important, because it influences the way that we see things, and it allows us to make good decisions about how we operate. I've had a lovely weekend. Things have opened up a little bit in the UK. So my youngest son got married on Saturday, and it was a wedding that had been postponed. He was supposed to get married last June. Obviously he couldn't, but he got married at the weekend, and 30 of us were allowed to be at the ceremony, so long as we were all sat socially distanced, and it was a lovely event. But while I was down there, I saw another friend of mine, and he was very worried because he'd heard that the vaccination that he was due to receive, there's some very small evidence that it can lead to blood clotting, and he's already had a blood clot, so he didn't want another one. But I was managed to persuade him by showing him how small that chance was, that it was well worth him getting vaccinated. So I'm pleased to say that he has. By consulting mathematics, he's decided to make himself very much safer. So again, his understanding of mathematics, and maybe his trust in a mathematician, impacted on the way he understands the world. So mathematics is that important. That's why mathematics is important. So it's not just that we're teaching children to pass examinations, which of course is important. It's that we're teaching children things that might might support them all through their lives. So this is the outline of what we're going to look at over the next 3/4 of an hour or so. I want to think a little bit about what we might mean by catching up. I want to think about what we might do, how we might assess students, where they are in terms of their mathematical knowledge and the things that they've learned on their return to school. And as I say, this might now be looking forward, or it might influence the sorts of things that you're doing with them as part of remote learning. Then we'll think about consolidating understanding, and what I'm going to use there are a series of what we call low threshold, high ceiling tasks. I think one of the things that you will certainly be needing when students start again, when the children go back into school, is activities and tasks that they can all access no matter what they've been doing over the last year. So you want everybody to be able to access something, but take it as far as they can. So there are different endpoints for the activity, and that's one way of you being able to understand where they are at the moment, and it's a way of you being able to think about what you might want to do next. And then in the final part, we'll slightly change tack to look at the CPA approach to learning mathematics. What I did as I was putting this webinar together, and it's always nice doing new webinars because it makes you think in a different way. I thought, well, how will I kind of think about these issues? And decided that what I would think about is what I would hope would be happening with my grandchildren. So I've 3 grandchildren now, 3 grandsons. They all live near Manchester, in the UK though, not in Jamaica. Felix, who's 8, Tate, who's 3, and Quinn, who's 6 months. He was born on Christmas Eve last year, Christmas Eve baby. A real Christmas blessing. So what I'm talking to you now about is what I would hope will be happening for Felix. The sorts of activities I would hope that his school will be doing with him. And I work with his school. I run sessions for them as well. And the first thing I have to say is that he absolutely loves being at school. And one of the things that he missed most over the lockdown in the UK was being at school and was being with his friends. And Felix is the little boy there in the red trainers, trying to catch up to the girl in front. And I wonder if that's a kind of metaphor for what's happened in the last year. If we were talking about a running race, and if the running race had been paused, as in that photograph, the children would all remain in exactly the same place. Then when we restarted that running race, we wouldn't necessarily be thinking that they should all be another 5 times round the playground. They would actually start from where they were when time was frozen. And imagine running laps of the playground from the next 8 years. So Felix will be in formal schooling for the next 8 years. We're certainly not going to be worrying about the fact that maybe he missed a few laps of that school playground. We'll be much more interested in where he is at age 16. John Mason, who's a mathematics educator in the UK, and he's done a lot of work internationally. One of the things that he said that I keep coming back to for all sorts of reasons is that teaching takes place in time, learning takes place over time. So the learning continues after every single lesson that we've been teaching. Children don't stop learning when we stop talking. You'll not stop learning from this webinar, I hope, at 3 o'clock UK time. What time will that be in the Caribbean? Somebody can tell me on the chat. I hope, and certainly if it's a successful webinar, that you will carry on thinking about it. And that when, thanks Delicia. So at 10 a.m, Delicia, I hope you don't stop learning from this webinar. Maybe I hope you start learning from it because you're having time to reflect and think about what it is that I'm saying. And it's the same in terms of teaching mathematics. Two examples, two reasons why I believe that statement to be true. I started teaching in secondary schools in a place called Sheffield in the north of England. And it was a school that was described as being in challenging circumstances. So we were working with students who had lots of disadvantages, lots of things to cope with out of school. And we did our best to support them in school through the challenges of their lives. And I remember a couple of years after one student had left school, so he left school at 16, and a couple of years later, age 18, I was walking through Sheffield, and I was on the road and opposite the library, the main public library in Sheffield, and I saw this lad. It's called Stuart. Saw him across the road, and he waved, and I waved back, and I was quite pleased he'd wave because he could sometimes be very, very difficult when he was in school. And he ran over the road and said, "Oh, sir, how are you doing?" And we had a bit of a chat. And then he said, "Will you take me into the library because you'll know where things are in the library?" So we went over, and he was looking for books to help him. He'd just restarted his education at a college. And I thought there was something there about learning taking place over time. He knew that I was interested in his learning, and he saw me fortuitously maybe, and he thought Tony is the sort of person that'll be able to show me where the books are that I need, and that hopefully got him back on track. As I was planning this webinar, I got a message on my phone, I got a text from an ex-student of mine who I taught maths to 35 years ago. So I was teaching him as a 16-year-old, I was teaching him maths. Now we've kept in touch for all sorts of reasons. That's always a good sign. Again, this thing about teaching takes place in time, learning takes place over time. If you remain in contact with your students, you know that's the case. If you remain in contact with your students because of the community that you teach in, you're probably a little less concerned about this idea about catching up, because you will feel as though you've got a sense of there being time available. So let me just read you a little bit of this text. So this came through, like I say, a week ago. Sunday the 16th of May 2022, 8:20. And this is what John says. So I've been watching a few maths videos on YouTube recently, and today on my run, he's a runner, I go out running as well, I had an epiphany concerning trigonometry. I remember sitting in a temporary classroom with you at High Green School, which is where I taught in Sheffield, and you explaining the value of √3/2 and the square root of 2. At the time, I really don't think my heart was in it, and I gave up. And then I found out about radians. Now, don't worry if you don't understand the terminology. I think you'll get the sense of what I'm talking about. Why don't we teach kids about radians at school? And then he talks a little bit more about technical things in terms of maths. Then he says, I'm still some way from truly understanding the wonderful relationship between the circle and the triangle. But the more I consider it, the more I see the abstract wonder of it all. Thanks for being my maths teacher back then. I was a terrible student who really didn't try very much, but you should know that at least something got through, and the fact that I still want to understand 35 years later is testament for your enthusiasm for the subject. Now, if ever there was evidence of learning taking place over time, 35 years after a lesson that he remembers, and he remembers himself not being very interested. I don't necessarily remember that as being the case, but John remembers not being interested. He's becoming interested in mathematics. So those two extended stories are to try and persuade you not to panic about this message about somehow everybody falling behind. People are always at different stages of learning mathematics. People are always at different stages of understanding mathematics. Even within mathematics, people have different understandings of the different parts of mathematics. So in some ways, they'll be at different levels or different places, depending on whether you're thinking about number or shape or data handling or measurement. So there's not a kind of consistent placement of people. It isn't a race like that image. There's all sorts of different journeys going on. So I'd actually avoid using the word catcher. I'm trying to avoid using that word because it kind of gives an indication that there's somewhere where somebody should be, and because of the lack of experience for you, they're not there, and we've got to get them there really quickly, or else they can't be efficient in terms of mathematics. And rather than that, I want to kind of give that message about everybody will be at different places when they restart school, as they always are. And what we can do as good teachers of mathematics is work out where they are, and that can actually help us think about what to do next. And maybe one of the things that we can do with our students is give them confidence that they've got plenty of time to learn lots of mathematics. And that this isn't just something that's happened in Trinidad and Tobago or Jamaica. It's happened all around the world. So everybody has stopped going to school. So we can't even say that it's because a country has dropped behind another country. We've all stopped. We're all frozen in time, like that image. And hopefully what we can do when we start up again is start from that place. We've had a year doing interesting things and doing different things, and that'll impact on how we develop. But what we need to do is make time for us to find out from the students where they are, and then we can make sensible decisions about how to move on. Another mathematics educator who's just written a book about mathematics teaching and care, both care for the importance of mathematics and care for the students who are learning mathematics. So that asks us to not talk at, but make time to listen to. That's part of the reason that I wanted to open the chat early, and that whenever I'm doing these webinars, I do open the chat early. It gives me a bit of a sense of where you're starting from, what your current position is, and gives me a bit of a sense that I know something about you already. So I wondered to myself, what might be my first lesson when I quite often imagine grade 3 classes, because I can imagine Felix. And this was it was also a real life piece of planning for me, because one of the other things I do is that I'm working as an online maths teacher for children in a refugee camp in Greece, in southern Greece. So they're mainly Syrian children who are escaping the war in Syria. As you can imagine, they've escaped from the most horrendous of circumstances, but they still want to learn some mathematics. And they want to learn particularly mathematics and science, because they think that will give them access to careers and jobs when they grow up. And quite often what they want to do is go back and change the country that they've come from in order for it to be a safe country. And again, I thought, okay, so what might I want to do in terms of first activity with them? And this is what I decided. It's off a website called UCubed, which is from Harvard University. And it might be, if you after this webinar, I'd suggest going on the UCubed website. There's lots and lots and lots of really useful activities, and they're all fairly straightforward, and they're all fairly open. And those of you that are working by sharing resources with children from school, because they've not got access to the web, could quite easily set something like this up. And the part of the reason that I chose this activity is because it does kind of take some care about welcoming people, and it does give kids space to talk and compare the experiences that have been going on. The activity, and I'm going to ask you to do a little bit here, is you'll see animals there. There's what I would call a ladybird. What Felix told me was a ladybug, because he watches a lot of television from the States. I guess you might call it a ladybug too. An ostrich, an octopus, a moose, and a snail, and they're all joining a procession. I'm taking Felix and Tate to a zoo on Friday, so we can actually do this activity in real life. Can you think about a parade of animals for me that has 20 legs, and just write down that parade, maybe in order, in the chat, and that parade has to have 20 legs. A parade of animals with 20 legs. Gives me a chance to have a little sip of coffee. So put your parade in the chat. I always like to see the someone is typing icon coming up, so that shows that somebody's taking some notice. This is an activity that I used in the first lockdown. I'd been doing quite a lot of online. We were using Zoom with Felix, and fairly quickly his friends wanted to join as well. So this was the first activity I did when we had a dozen or so of his friends. Okay, 5 cows, an octopus, an ostrich, a ladybug, and a moose. Another one, somebody apart from Nikisha or Joan. Gabriel, do you want to put your parade up? So Nikisha is already doing the 5 fours. You don't have to, Nikisha. You can do if you want. I was quite happy that you didn't, because suddenly we'd extended it. And I think part of the joy of activities like this is that people can take control of it themselves. So often when I'm working on activities, I don't have a particular one or a particular way that I want you to do things. 10 ducks, spider, cow, cat, dog, horse. Great, Gabriel. So and we can do all sorts of different parades. And then fairly quickly with this activity, Felix and his friends were deciding on how many legs. Then I slightly changed the activity, and I was asking them for particular numbers of legs and heads. So I might say I want 20 legs and 4 heads, and so Joan's answer would be fine, but Nikisha's answer wouldn't work. So we could. Spider has 8 legs, doesn't it? The ladybug has 6. A spider's not an insect. I think I was hearing on a. I'm fairly sure a spider has 8 legs. 8, 10. Are you saying that Gabriel 4, 8, 10, 12? Yes. So Gabriel's is okay. I was just quickly checking that. So 10 ducks would have 10 heads, but a spider, a cow, a cat, a dog, and a horse doesn't have 10 heads. But of course, we could just add any number of snails as we wanted to that to make 10 heads, which is what the kids started to do, because that was a 0. And that's quite a nice way of thinking about the impact that 0 has, and what 0 means. Fairly quickly, the kids, Felix's mates, started taking control of it themselves, and one of them said, "Well, I can think of I've got an animal with six legs and 1 head." So I said a ladybug, and they said, and that Felix said, "No, it's a moose-strich." So he was inventing new animals. And we had an octomoose, which had 12 legs. So suddenly that got us into all sorts of different places. So as a first activity with some kids, and something like this as a first activity, but it's interesting, it's fun, it starts to give you an idea of where kids are. But what it also does is it starts to slightly shift what they might have expected in terms of maths when they get back to school. I think some of the students in the UK, some of the children in primary schools, were expecting to kind of have a test on their own quietly, which would tell them how far behind they were, and then they'd have to work really quickly. And this gave the opposite sort of message. Now, other things that you might be able to do as and when the children return, one of the things that I was kind of thinking about, what might I do, is if I'd set this as an activity for home learning, what I might do is ask the children to work in groups on this same activity, but talk about what they'd done at home and the way that they do it. So they were comparing what they'd done when they were working at home. And then you would start to hear the differences about who'd not been able to access the internet, or who'd not been able to start on this activity because they'd not got the resource delivered. Or so you find out all of those sorts of things as the children were doing some mathematics. So it would give them a chance to share stories. And I think one of the things that's going to be quite important when kids do start school is giving them the chance to share those stories. It's been a momentous event in all of our lives. I was thinking about Tate, who's 3. A third of Tate's life has been under the pandemic. So if you've got an 8-year-old, some of you are teaching in grade 3, a year out of an 8-year-old's life is much greater proportion of their lives than a year out of a 35 or 40-year-old's life, and certainly much more than a year out of a 62-year-old's life. Quinn has known nothing but people saying hello to him wearing masks. For Quinn, age 6 months, that is the norm. It will be strange when he starts to see people's mouths again. So I think in school we need to give kids time to discuss these sorts of things. And the reason I think it's important to do that in maths as well as in other subjects is because it gives the message that maths is to do with real life, and maths is to do with everything that's going on, which is right back to that first example that I gave you. Now, another possibility is, so say you start back in September, say there's a whole year out of schooling and you don't start back until after the summer break. What I might do is, in groups, I might say, okay, if you had all of your last year's learning, this would have been the assessment at the end of the year. I'm just interested in knowing what you've been able to work on and what you've not been able to work on, because that will give me a way of prioritizing what we need to teach. And that they would do that in groups. If there are questions there that they have no idea how to answer, they just leave that blank, and that's useful information for me. And if there are questions they can have a go at, that they do that collaboratively and in conversation. So it's that thing about giving them a chance to talk again, but it also gives me very useful information. And what that gives us is formative rather than summative assessment. What I don't think would be a good idea would be to give kids a summative test, and that's the example of a summative test at the end of a unit from Explore Maths that they do on their own and silently, because that will give them the idea that somehow they've fallen behind. But if they work on that kind of an assessment as a group, it prioritizes their relationships to each other, which is something that we want to do so they feel safe and secure back in school. And it prioritizes a relationship to mathematics, which we hope is something that they can do, and something that there's, like I said before, there's plenty of time to work on. So thinking a little bit about the sorts of activities that you might do in order to bring children back into the classroom. It might actually be that some of these activities might be things that you'd be able to use at the moment with the students. And what I've done is that there's a series of about 5 activities across the different areas of mathematics, just to have that think about how we could have, like I said, low threshold, high outcomes, so that the kids can everybody can make a start, but they can take this to different levels. So all of the next 5 activities are things that I've worked on with students from age 6 or 7 right through, some of them to university level mathematicians. And I've said there, more time over less content, if you like. The broad idea of content, the broad idea of mathematics, rather than very specific content. So there's a number grid. Imagine that going on in all directions. Can I just ask you to put in the chat anything you notice about that number grid? And this is the way that I would start it with children in school. Tell me anything you notice in that number grid. Okay, so Delissa, you can see odd numbers, and because I've said that extends in both directions to infinity, as far as you could see, that would mean that all of the odd numbers appear in that top row. Does anybody notice anything else about that grid? Absolutely anything at all? That's great, Joan. Each row is increasing by the number ahead of it. So 1, 3, 5, 7, 9 increased by 2, which is the starting number in the second row. 2, 6, 10, 14, 18 increased by 4, which is the starting number in the row below 2. Anything else? It's always interesting using this in the classroom, because whenever I do it, there's a sense that from the children or from the students in secondary schools that there's something that I'm looking for, that there, and because as I've just done now, I'm saying that's great, and what else, and what else, and what else. Sometimes there's a feeling that they've not got the answer I want yet. And then fairly quickly, when people get to know me, they know that there isn't an answer that I want. I'm genuinely interested in what people are noticing in the grid. I'm going to wait for whoever this someone is, and then we'll move on. Thank you, Joan and Delicia, for Nikisha's noticing the row by column multiples. So do you mean 2 times 3 is 6, 2 times 5 is 10, 2 times 7 is 14? That's one of the difficulties you see in with using webinars and virtual platforms. It's harder to have that conversation. Great, thanks Nikisha, but it doesn't take too much time. So three things you've noticed there, and we take quite a long time exploring all the sorts of things that we'd noticed. And then a question of mine might be, well, do you think every number would appear? Now, we'll not work on that now, and I'd give you plenty of time to think about that. I'll just give you I'll explain the sorts of things that people have said to me. And it might be that somebody might say, well, all the odd numbers are going to be there because of noticing that top row. So I might say, well, do you think all the even numbers are there? And, well, I can see 2, 4, 6, 8, 10, 12, 14. Oh, I can't see 16. And we might think about that for a bit and then realize that 16 will be underneath 8. Yeah, Nikisha. So all the greyed ones rather than the blue ones are even. So we can start to think about if all the even numbers are there. And whilst we're doing that, we're thinking about odd and even. And it's not just even numbers up to 20. Sometimes I think children think that even numbers stop at 20 because they learn it at that stage of their counting, and they don't realize that odd and even goes on forever. So we will work on that. And then I might say, well, if you do think all the numbers appear, do they appear just once, or do they appear more than once? And somebody might say, well, the odd numbers only appear once because everything underneath, as Nikisha said, everything in grey is even. So there's only one place for the odd numbers to be. So then we can start to think about if the even numbers only appear once. So you can see all of the mathematics that's coming out of, and the mathematical conversation that's coming out of an activity like that, which again allows me to know where the mathematical thinking is in terms of the students that I'm working with. And whether they become more or less confident in mathematics, whether they're still able to use terms like odd and even, multiples, all of those sorts of things. As children get older, and the reason I've been able to use this in university is that they start to use algebra to explore that. So in secondary school, we would use algebra to explore this. But there's so much mathematics in there from a very simple, straightforward starting point. Now, I'll talk through these quite quickly so we can have a bit of a chat about CPA. Another thing I think I would be doing, and I know from I have visited Jamaica, is that there's usually outside space, and it's great to use the outside space. So if I'm thinking about shapes, I'd be going outside with my class with ropes, and making all sorts of different shapes and listening to the sort of conversation that they would be having to make a square. And I might be saying we might even build on social distancing, because I think it's quite useful to allow that gives them permission to talk about how they've been feeling for the last year or so. And you can see the little boy in the top right hand corner making a square. It's a bit like the Leonardo da Vinci figure making a square. Make a square so that you're all standing 2 meters apart from each other. Then we can think about how big is that square. Make me an equilateral triangle so you're all standing 2 meters from each other. What length does that make each of the sides? If we've made an equilateral triangle, how do we turn that? How do we transform that into an isosceles triangle? And so on. And using that question about what's the same and what's different. One of the things that I was doing with Felix and Tate when I was doing their online maths lessons was, if we were thinking about shapes, and I might use a little bit of film off YouTube to show them some shapes, I'd ask them to go outside during the rest of the day and find me squares, or find me circles, or find me 5 different sorts of rectangles. Now they're lucky they've got the mum's phone that they can take photographs on. But working with other kids, working with these kids in Greece, they can just tell me. They just go and look for these shapes, and then the next lesson they will tell me where they've found them. Something about being systematic. So all of these things are about the big ideas in mathematics. I hope you kind of noticing about being mathematical. Now, if we can use the return to school to develop children's being mathematical or mathematical thinking, that will allow them to learn more economically later on. So we can focus on developing their mathematical thinking, which will actually allow them to speed up later on. Going back to that image of the running race, I guess it's a bit like doing strength and conditioning work. So what we don't do in order to catch up is just keep running and running and running and running. We might stop and say, right, we need to focus on technique. We need to focus on you getting strong. We need to focus on diet, and then you'll be able to run faster in order to catch up. And I think this is sort of what I'm talking about in terms of developing mathematical thinking. So developing the idea of being systematic. How many different ways can you arrange 4 different colored cubes? This is the way that I would do it if I was working offline. If I was working in the classroom, I would get 4 children. How many different ways can they sit in a line? And you can see there we're starting to think about how we might record that. So you might record that with initials. And if that's proving problematic, we can say, well, okay, how many different ways can one person sit? Well, just one, Tony. There's only one way. Well, what about if me and Joan were sitting at the front? How many ways could we sit? Well, it could either be Tony and then Joan, or Joan and then Tony. So that's 2 ways. Okay, so Gabriel and Joan and Karina are all sitting at the front. And I might now start in it. So it could be Gabriel, then Joan, then Karina, or Gabriel and then Karina and then Joan, both with Gabriel sitting first. Or Joan first, Gabriel and Karina. You see what I'm doing? I'm being systematic. And then we can think about 4, and then we can think about 5, and then we can start looking at patterns. Some things that's the beginnings of algebra, or this is another activity that I've done in secondary school, and we've used quite complex algebra, and I've used it with 5-year-olds, and we just keep a record. We've just come back to school. If everyone in the class shakes hands with everyone else, how many handshakes altogether is that? And it's similar. I think you'll see that it's similar to the previous activity. We can also link this with transmission of viruses. If there are 5 people and they all shake hands with each other, how many different people, how many opportunities have there been for the virus to be passed on? And the answer can be drawn. It's called a mystic circle. So if you imagine each of those dots around the circle, they're called nodes. If you imagine each of those dots is a single person, you can see that each of those dots is connected to each of the other dots. So we could find the answer by counting up the lines. And again, we'd start off by going small. We'd try with 3 people and then with 4 people. We could work on a data handling project. This is at the end of each unit in the Explore Maths, there's a cross-curricular inquiry, and one that seemed quite apt for this was around healthy hearts. So there's all sorts of data handling projects that we could do around health, around keeping healthy, which goes back to the idea about giving permission to talk about what's been going on for the last year. Okay, I want to just switch for the last 5 minutes to thinking about CPA, and I've deliberately just left this for 5 minutes because there's been previous webinars around CPA, and I guess it's not the thing that's uppermost in your minds at the moment, but it's something that we've been asked to cover. CPA stands for concrete, pictorial, and abstract, and it's gaining hold. It's seen in Singapore maths. It's actually something that's been going on for a long time before Singapore maths. It's come from Jerome Bruner, from an educational psychologist and theorist called Jerome Bruner. And what he was doing is exploring how children learned mathematics. He wasn't a teacher. He was somebody who was exploring how children learned mathematics. And he suggested that there was a schema, there was a kind of route that children went through, that they start off concrete, they start off needing objects to count or to move around, to manipulate, and then they would move on to drawing pictures, which were images of what they'd been doing with concrete materials, before they went on to being able to use abstract numbers. And there are 2 examples, again, from lockdown. I know my grandchildren are able to have access to resources. So there's Tate filling a 100 grid in different ways. Now, he wasn't counting to 100. He was just finding different patterns that could make 100. Age 3. He'll carry on doing that for 2 or 3 years. Then he'll start to notice the numbers. And that's Felix, aged 8, using Cuisenaire rods and starting to find trains. So he's seeing there that 3 greens are the same as a blue. So we could say that 9, if we say the blue is 9, 3 plus 3 plus 3 is 9. If we look at the bottom pattern, 2 plus 2 plus 2 plus 2 plus 1 is 9. So he's using concrete materials to start thinking about the numbers. It doesn't always happen in that order. Sometimes kids will be confident enough to start with abstract things, but you'll probably see, if you think it through, that from early years through to the end of primary, there is this kind of shift from concrete to abstract. And what Bruner said, and what somebody called Martin Hughes said, is there's an iconic stage, and the iconic is the same as the pictorial. So if I'm working with 4-year-olds and they've got 5 counters in a box, and I take one counter out of the box and close it and say to them, how many counters are there in the box now? They might draw a box with 4 things in it and draw one thing outside of the box and count the 4 things in the box. So they will draw a picture of exactly what they've just done. As their thinking develops, they'll move to an iconic stage, and what that might be is that they would draw 5 lines to represent the 5 counters in the box, and then cross one of the lines out to show that one had been removed from the box, and then they can count the lines. So that's iconic. And the abstract is when they would actually say, well, 5 minus 4 equals 1. So just a quick whiz through what that might look like in terms of a textbook or your work. So there you can see 2 different images. A concrete image, so for 6, I can count 6 dinosaurs, and I could actually touch the page and count those 6. The iconic stage, or the pictorial stage, if you like, is where there are the dots rather than the dinosaurs. And there I'm starting to see 6 as 5 plus 1, 7 as 5 plus 2, because I can see the way the dots are arranged. And the abstract is just using the symbol or the name. Another way of starting to think about how we can have a picture that represents something that's concrete. If we look at the first image there are altogether 9 flowers. There are 3 in the jar. There are 6 out of the jar. So what I can do in terms of that diagram is I'd be writing a 6 in one of the circles and a 3 in the other circles. They're called PartWhole Diagrams, again, something that comes from Singapore. And then one way of interpreting that is saying, well, 9 minus 6 equals 3. And of course, another way of interpreting that would be 9 minus 3 equals 6. As the children get older and move through primary school, starting to use place value material as the concrete representation of a number. So then there you can see 27 represented as 2 longs and 7 ones if we're using place value material. We can also represent that on a 100 grid. That's another pictorial representation. So if we were wanting to add 7 onto 20, we can count 7 squares on in the 100 grid. Or we can have 2 longs to represent the 20, 7 ones, and count 20, 21, 22, 23, 24, 25, 26, 27. One final one. When we're starting to think about multiplication facts and division facts, we can represent those pictorially as an array. Now, when if I'm first doing this, I would actually use counters or bottle tops or something concrete and say, you've got 16 bottle tops there. How many different ways can you arrange them in an array? And you'll see that top array, there's 36 in that top array. And what we can see there is both 9 times 4 and 4 times 9. If we had 16 bottle tops, we'd be able to, a long row would be 1 times 16. We could have 2 times 8. We could have 4 times 4, which would be a square, and we would start to be noticing square numbers. And you'll see there that square numbers are coming out of an image rather than a fact that I'm just telling them. So I hope that brief 10-minute run through CPA has just kind of unpicked that for you and made a sense of it. I think the one thing that I always want people to take away from thinking about complete pictorial abstract, it doesn't mean that what we have to do is make our kids draw everything that they're thinking. It's more to do with them being able to manipulate objects concretely to help their thinking, not have to record everything exactly as they see it so they can move to that iconic stage, and then being able to see the connection between perhaps a picture that we give them, a representation that we give them, and an abstract mathematical sentence like 9 times 4 equals 36. So it was 5 minutes before 10 o'clock with you. Have any of you got any questions? First thing I want to say is thank you very much for engaging and for joining in. These webinars never work if people just sit quietly at the back and don't ever put anything in the chat. So thank you all for putting things in the chat. But have any of you got any questions?
Thank you all very much for joining. I see that somebody is typing something, but just to let you know that you will receive a certificate following this webinar, and then within the next week you will get a recording of the webinar plus Tony's slides, so you can review them and practice and share with your colleagues.
Thanks, Delicia. What did you find most useful, Delicia, just out of interest? Always helps me because I'm doing this one again later on, so it will give me a sense of what was most useful for you. Okay, right. I'll perhaps give a bit more time to CPA this afternoon.
Great.
I know that it's something that's being thought about quite a lot in the Caribbean. So those examples were from the Belize books. So there's Belize, like a lot of the places in the Caribbean, has just changed their curriculum, and these are from the new set of textbooks that we've written for the Belize curriculum. Any more questions from anybody? Someone is typing. I think because they will have, they will all be at such different places that what we can't assume. It's a bit like when kids start school, isn't it? It's very tempting to assume that they don't know anything when actually they're bringing all sorts of things with them, and what we have to do is find out what it is that they do know, which is what I was talking about early on. And I think using open-ended activities that they can do. The most important thing is that they're able to access the mathematics that we're offering them straight away, because that will give them confidence that they're able to move forward. And it will also give us information about what they can do, and then we can use that information to plan the next thing that we need to do. I think it would be a mistake for us just to go kind of either straight into to next year's curriculum, or assume that they haven't done anything at all and just repeat the year. We certainly need to be quite careful in the first few weeks to find out exactly what it is that they can do, but make the maths lessons places where they're being successful. Good.
Okay, well, thank you, Tony, very much indeed for a very informative and interesting session, and I hope everyone enjoyed it, and thank you very much for your time.
Bye-bye, everybody.
Bye-bye.